Thank you, Pontus and Gabriel, for having me here. And this is going to be my first talk at a remote meetup. So I really hope we can have some interactions during the presentation and probably after it to make up for the situation somehow. So I called this talk A Road to State Machines. I changed the title a little bit. And what I want to do here is I want to explain the concept of state machines applied to state modeling on a practical example. So what we are going to do here is we're going to implement a little feature together, and we will see how it's going to work out for us. And the road here symbolizes that we are going on a little trip where we will start by implementing this feature in a simple and naive way, which will prove to be buggy. And this will mean that we're going to have some hinders on the way, but we're going to make a stop. We're going to analyze the hinders and we're going to change the course so that we can finally arrive at a much safer and more robust solution. And this is going to be the destination of our road trip this time. So let's see. A little introduction about myself. My name is Margarita, and I'm originally from Ukraine, now living in Sweden, Gothenburg, where it's raining quite often, but today, surprisingly, it's really sunny. It's even a lot of light right now. So I'm a software developer and I work at a wonderful place called Antura in the heart of Gothenburg. And here I'm focusing on React, TypeScript, we have a little bit of Reason, and we have also introduced GraphQL and Apollo on the front-end side. And I'm also working with F# and C#. On my free time, I am trying to learn function programming more, applying it with languages like F# and Reason. And I'm also writing old dev too, mostly about Reason. So before we start, I just wanted to mention a bit that this talk assumes some very basic knowledge of functional concepts like variants or discriminated unions in other languages, pattern matching, a little bit pure function, and immutability. And all the examples I'm going to give here are going to be in ReasonML, but I think it's pretty easy to translate them into other languages like Elm or F#, for example. This is also going to be a beginner introduction to state machines. So if you're a real experienced user, you probably won't find anything new for yourself, but I think it's still going to be fun. So a very fast agenda. First, I'm going to say just a few words about state machines. Then it's going to be enough for us to pack our bags and drive out for our little journey. Then we're going to do a little recap about state machines. We're going to talk briefly about benefits and how we can recognize state machines. So let's start with a state machine. In its essence, it's a mathematical concept that became a design pattern in software development. And as we know, many useful mathematical concepts from category theory are used in function programming. So as a state machine is not an exception and is also used in domain modeling. And domain modeling we can understand as representing data and behavior of a concrete area of our application in code. So that's basically it for a little introduction, and I think we are ready to start our little journey. And I mentioned that we are going to implement a feature where our domain is going to be just simply user. So let's imagine that we're going to have a website where we can see and browse a list of products. And maybe we also want to post questions about these products. And in order to do that, we need to track our users. Let's say that, first of all, we need to know whether the user is logged in. So let's just simply start with a flag, which we're going to call isLoggedIn. But then we realize that we need to also track some data for the logged in user, which we're going to represent with username and email. So since this data might be present, might not be present on our user, we can say that we should represent it as an option because this is what we know is kind of a good way to do it. So we add an option here. So now we have a flag is logged in and we have user data. So this already might feel a little bit weird because those fields are really dependent on each other. But let's say that we continue on this track because it's kind of simple to start with it right now. And then a really tricky requirement comes in, which says that not only logged in users should be able to post questions, but even users that are not logged in, but have a temporary username. So if you just want to post a question, but don't want to bother logging in, you just want to assign some temporary name for yourself and post something. And let's say we add this as another field, which is also of type option, because again, it might be there or it might not be there. So this is the data structure we end up with right now at this step. So next step, we want to implement some functions that work with this type. Let's see what those functions are. First of all, we have this function that is going to set temporary username when the user, say, enters something in an input field and presses a button to set the name. Next one is when the user wants to log in, and we have already fetched users data here. So we need to remember to set is logged in flag to true and also user data, assign it here. And the last function I'm going to show here is going to be logout. This one is going to simply set is logged in to false. So let's imagine that we have those functions here and we are going to call those functions in response to some user input. Like when the user presses on the button logout, we're going to call this function. We're going to change our user and we're going to set it again on state. So we kind of ready here. Let's, as the next step, we're going to implement our post question functions, which is going to look something like that. First of all, we need to make sure that only the users that have either temporary username or user data can post questions. So what I'm doing here, I'm pattern matching on a tuple of the temporary username because it's of type option, and user data, which is also of type option. And depending on the outcome, I'm using the correct name. Otherwise, I simply fail because this should not be allowed. And let's say that the last step, this is going to be a function that will do some side effect, maybe go to the API and pose this question. So at this point, we kind of think that we are done with our little feature, and probably we are approaching our destination with our little road trip. But suddenly it feels like it's really far away and our destination just fades away, because instead of users being curious about our products and posting questions, we get instead a lot of support questions from angry and confused people that are not satisfied with this new feature. So why is that happening? First of all, we get this one. There is a user that is really angry because he just set his temporary name while being logged in just by mistake. And the user is stuck with it. It's always there when he posts questions. So let's analyze why this happened. This is because with this function, this should not be allowed when the user is logged in. And we didn't really account for that. We are just setting this temporary username because there is nothing preventing us from just doing that. And this is wrong here. Next one is from a really confused user who says that I logged in, but it still shows my temporary name. And this happened because the user first entered his temporary name and then logged in. And what's going to happen now? And this is because when the user logs in, we remember to set both those fields, but we forget about clearing temporary name, and it's still there. And we're basically stuck with it. And this is again because we allow this to happen, and it's really easy to miss. Then we also have a user that is really happy and he thinks that he hacked our system because he just logged out, but we're still able to post with his username. And this is because of our third function, where we set is logged into false, but we obviously forgot to reset user data here. And again, we just allowed that to happen. So what could be a solution here? First of all, we could just add a bunch of if checks, we could add pattern matching, we could fix our post question function where we actually relied on order of temporary username and user data being present, which was also incorrect. So we could just try to fix it, but that would introduce even more spaghetti code. That would be even more difficult to follow, to extend. So I think we can do better. And I think we are getting on the right track here. But let's analyze it even deeper and see what actually happened and why we get so many bugs with our solution. First of all, we allowed many invalid combinations when we created our user type. So let's look at it again here. Here I have the user type. We could potentially have is logged into true, no user data, and temporary username. We could just mix them any way we want, and it's going to create a lot of invalid states, and we don't have any protection against it. But in essence here, we only have 3 states. The user is anonymous, temporary, or logged in. And we only can be in one of those states at a time. So this data structure was essentially wrong to its core. So we just had a lot of implicit states. And just a sec. That made it really difficult to keep track of what properties belong to the same state, which made it really difficult to update those properties correctly and keep them in sync. And that also led to different bugs that we saw earlier. So like in this function logout, we just forgot that this one and user data belong to the same state, and it's really easy to miss it. So we didn't really update it. One more thing, user inputs were implicit too in our system. And what I mean by user inputs is when the user presses on login, logout, or set in temporary username. Those are all user inputs. And it was really difficult to see the connection between the states and the inputs. But this connection definitely exists, because when you want to log out, your user input is log out, so you want to transition into the state of being logged out. So there is this connection. So let's see how we can fix all those things that we just analyzed. First of all, we want to make our states and our inputs explicit. So here is how type user would look when we model it explicitly. Since we realize that we have only 3 states that the user can be in, then it's a perfect case for a variant or discriminated union in other languages. If the user is temporary, then we want to attach some extra data. We don't have options anymore. That is completely eliminated. So temporary user can have a temporary name, which is stored as string, and logged in user is going to store the same user data as we saw on the very first slide. And let's look at our inputs. They are also going to be explicit, and it's also a perfect case for a variant or discriminated union, where we can also attach some data. When we want to set temporary username, we want to pass that name together. When we want to log in, we have user data, log out, it's not going to have anything. So next step is we want to figure out how to connect our state and input. And this is we're going to do with the help of a transition function. Since this is a formula for transition function, we already figured out that when we receive an input from the user, it really depends on the current state where we can transition. So we cannot, when the user wants to log in, we cannot just immediately become logged in, because it depends on what the current state is. If I'm already logged in, I should not be able to log in. And the same works for all other states. So this is a function that we will have to implement here. And this is the function also where we're going to define behavior of our user and how it responds, how the user is going to respond to external input. And there we want to cover all possible combinations of state and input. So the number of those combinations is going to be the number of states multiplied by the number of inputs. In our case, we have 3 states and we have 3 inputs. So essentially, we need to cover all 9 combinations here in our transition function. So at first, it might seem a little bit overwhelming that you really need to go through all 9 combinations. Some of them are going to be invalid. We need to handle them explicitly. Some of them are going to be valid, and we also need to handle them. So a good strategy here is you can just take a piece of paper, you can draw a table where you're going to have states and inputs, and you're going to go through all combinations. One other way here is that you can visualize your states and how you're going to respond to your inputs. So let's try to do it with just a simple diagram. We always start in some initial state. In case with our user, we're going to always start in the state anonymous. Then if we receive input set temporary username, we want to transition to another state, which is called temporary user. However, the anonymous user can also log in and become logged in user. Then temporary user can also log in, go to logged in user, or logged in user can log out. So as we can see here, we only have 4 different valid combinations of state and transition. So those are going to change our state. All the other invalid transitions are not going to do anything. They're just going to return the same state because this is essentially something that shouldn't happen. One more way to visualize state machines is to use an external tool, which is called XState Visualizer. And this is a part of a library called XState, which is the implementation of state machines for TypeScript and JavaScript projects. But we're not going to use it in Reason. We are going to just use what the language provides. So the way this tool works is that you define your state machine in a JavaScript object here. You specify what states you have. We have anonymous, temporary user, logged in user. And then you specify actions and what transitions are valid. And as you can see here, this is an interactive tool where you can click through your transitions and you can see how your system behaves. So it's a really fun thing to play with. Let's see. So now, since we have figured out that we have 4 valid transitions, we can implement our transition function. It's going to be quite a lot of code here, but we're going to break it down and look into it a bit closer. So in this function, I receive current state of type user, and I receive user input. And this function is essentially called when something happens from the user side, some event when the user presses a button, then I need to call this function and update my user. And the important part here is that I'm pattern matching on my state first and not on the input. If you have used reducer functions before, you might remember that you usually pattern match, you start with pattern matching on your action. But here it's a little bit inverted because the state machine emphasizes state, and it's state that should decide what the outcome is primarily. So we're putting a lot of focus on the state. And when we're pattern matching on the state here, in each case, we also need to pattern match again on the input to be able to take care of all possible combinations here. So let's see how it's going to look for when the current state is anonymous. Here we can see that we are covering 2 of the 4 valid combinations. We transition to temporary user, to logged in user. When we are trying to log out in the state of anonymous, we can't do that. So the only thing we can do is just return the same state. And we do exactly the same thing for our temporary user. We have only one valid transition, right? The other two transitions, we just return the same state. And you see the pattern, there is, you can do the same for the last case here. You might also wonder why I'm not using wildcard pattern matching with an underscore, because what we could do is we could just match on both user and input, only take care of the valid transitions and just return the same state for all other invalid transitions. In general, this pattern should be avoided, and I really wanted to stress on it and explain why it should be avoided. This is how it would look if I were to use wildcard pattern match. I would do switch on a tuple of user, current state, and input, only cover the 4 valid transitions. And the last step, I would do this. You might argue that this is less code than this, but there is a big problem here. In the case when we are handling all combinations, we're gonna get non-exhaustive pattern match warning from the compiler if we forget to handle some cases. And this is going to be really useful if you want to add a state to a user or add one more input here. So that's gonna prove really useful, and it might prevent you from forgetting to handle edge cases or any other bugs. But in this case, you're not going to get any compiler warning because this is basically going to kill it. This is something that I really wanted to mention. I think it's important to keep in mind. Let's see. Oh, this is also really a fun thing. If you're using Reason React, for example, and you are following this whole pattern with state machine, you have your transition function, it's really easy to use it in React component where you are using user reducer hook. So it's going to look like that. You essentially pass in your transition function as a reducer. It has exactly the same signature, so there are no changes here. And you pass in the initial state, which is going to be anonymous in our case. All the rest is exactly the same as you would use with a usual reducer. You can dispatch your action, and this is going to trigger your transition function and update your state and update your component. Then, of course, you can use your state machine in your UI. And I think this is really elegant. You pattern match on your state, and depending on the value, you decide what you're going to show to your user. Like in this case, we want to give the user some hints on whether he can post questions or not. So in case of anonymous, you can't do that. Temporary user, you can specify what username, and there's going to be the temporary username. In case of logged in user, it's going to be logged in user's username. So this pattern, I think, is really elegant here. So I think we have arrived at our destination. It's going to be final station, which is called state machines. We are done with our road trip. And maybe this example seemed really contrived to you. And maybe you even thought in the very beginning that it was clear that the model that we created was wrong. But in a more complex state where you have a lot of logic involved, you have a lot of properties, it's really easy to forget all this pattern and to just add a Boolean flag like we did in the beginning, like is logged in user. It's really easy to just do that or add an option. And by this, you're going to create more implicit states, which can eventually lead to all the problems that we just went through. So I think it might still be useful, even if it was a bit contrived. So just a quick recap of what a state machine is and how to use it. Essentially, you start with creating a variant or discriminated union for your states, and you can only be in one state at a time. That's also how variant works. You always start in some initial state. Then you go to your input or event, which is also represented as a variant. And then the last step is you create a transition function, which accepts current state, an input, and gives you the new state. I also wanted to mention that state machine is just a design pattern, so you don't have to use any library. It can be also introduced in a small part of your application, like I showed you with the use reducer. You can introduce it on a level of a small component. So you don't have to use it on a very large scale on your whole state. It might not even be appropriate there. It can also be used in any language and environment like TypeScript, JavaScript, but I personally feel like there is better support in functional languages because of variants and pattern matching, and also of course because of compiler warnings when you don't have exhaustive pattern match. And let's talk a little bit about the benefits. We have probably seen them already during our exercise, but let's just put them in a few sentences. First of all, you are protected against invalid states because you represent your states as a discriminated union where you know that you're going to be only in one state at a time. You are actually covered there. Then you are also protected against invalid state transitions because when you create your transition function, you are forced to go through all possible combinations and you know which of them are invalid. So you basically account for all edge cases at the same time. And I feel that it's really trivial. You just follow the pattern and you are covered there. All your edge cases are covered. And this essentially leads to fewer bugs, and we like it. We don't really like to have bugs in our code. This is also, I think, is really important. When you analyze the behavior of your system, you get to understand your domain better. Like when you go through all states, all your inputs, you try to analyze all possible combinations of state and transitions, you get much more understanding of the system. You might even discover that there are some potential problems in the specification of business rules of your domain, which is going to be really useful in the beginning of the project to prevent failure of it later on. Then I think it's pretty easy to use state machines. There is a clear pattern which you follow and you focus on the behavior, you focus on the fun part. And of course, it's really fun to visualize. So I am really happy with state machines and I really encourage you to use them. And the last one, I just wanted to quickly go through possible use cases and how to recognize state machines. First of all, Boolean flags. If you see is valid, is loading, is error, those are a little bit of a red flag that you might think about using state machines. Options like error, valid response. And if you have a lot of if checks and pattern matching on all those things here, then it's probably a red flag. It's probably a sign that you should try modeling it as a state machine. So now when I see this kind of type in code, I think I really look like this guy. So this is probably something to be avoided. And I think we are done here. I included some resources here. Those helped me really a lot when I was studying state machines. The examples here are in F#, but I think it's really easy to translate them. So I would really love to take any questions from you. Thank you very much.
Yes, thank you, Margarita. I'm gonna clap for everyone here since I'm the only one with the voice. But we have one, I think there's one question here. So the question is there any way to encode valid transitions in the type system so that it's impossible to accidentally go from logged in to temporary user, but instead require at compile time that it will have to be logged in, logged out temporary user?
Yes, I've had a couple of discussions about it on Twitter. It is possible with gets, I think. I'm not, I don't know really a lot of them. Is it generalized algebraic data types, if I'm not mistaken? It's like the new level of variance. It's pretty complicated for me personally, so I haven't really researched it much, but it is possible, definitely. The question is whether it's worth it. It might get too complicated. So you're gonna end up with much more code, much more complicated domain, which might not even worth it. But it is possible. I've seen people do it.
Okay. I think unless anyone else has any other question, I think that's it for now. I'm just gonna check one thing here. I think we've actually had a talk about generalized algebraic data types here on ReasonSTHLM before. But
yes, I was there.
Yeah.
I remember.
Not to say that I understood everything, but yeah.
It's very complicated.
Yeah. You can like climb the ladder of the type system to do more absurd stuff. But thank you for your talk.
Yeah, thank you very much for having me.